Hello friends, welcome to this third video on normal distribution. We will be seeing how to convert a problem which has been given in X into a problem into that of Z. Take the values from the table and find the corresponding probabilities for the same. We will move on to the problem. Problem number 1. We have been given that X is going to be normally distributed. So the keyword is going to be normal distribution over here. So X is normally distributed, and what is the second set of data given is mean is 12 and standard deviation is going to be equal to 4. We have to find the probability that X is greater than 20, X is less than or equal to 20, and X is going to be between 0 to 12. So this is going to be the value for which we need to estimate the probabilities. Now we will find the data, we will use the data which has been given to us. Given mean mu is equal to 12 and standard deviation, which is denoted by sigma, is going to be equal to 4. The conversion from the variable x to the variable z is aided through the transformation z is equal to x minus mu divided by sigma. So this is the formula which we need to keep in mind. So z is equal to x minus mu by sigma. Now we will take the problem number 1. What is the problem number 1? We want the probability of x greater than or equal to 20. We will try to convert this into a problem of z. So this will become z greater than or equal to. Now what will happen to this 20? So this will now become x is 20 minus what is going to be the value for mu. Mu has been given as 12, and then this is going to be divided by sigma. Sigma is going to be equal to 4. So z is 20 minus 12 by 4. So this makes it as 20 minus 12. So it is going to be 8 by 4. 8 by 4 is going to be equal to 2. So the region x greater than or equal to 20 in X corresponds to the region greater than or equal to 2 in Z. So this is going to be the conversion. Now we will plot the region and see what is going to be the area corresponding to it. So we will have our bell-shaped curve which is going to be symmetric about the point. So this is going to be the point z equal to 0. So where will be the point z equal to 2? This varies from minus infinity to plus infinity. So 2 is a positive number. From 0 to infinity you have the positive numbers. Say suppose this is going to be my point z equal to 2. Now where is the region we require? The region required is greater than that of 2. So whenever we want greater than that of 2, you will have to go beyond 2. So beyond 2 is going to be this portion over here. So this is going to be the portion greater than 2. So beyond 2. Now how to estimate this value from the table? You'll always have to keep in mind the table measures the data from the center only. So from the center only the data will be measured. But what you require is going to be a portion which is going to be beyond a particular line. So how to get the value beyond a particular line? Now we learnt about a clue word. To remember this by a shortcut way, GST. Greater means subtract. So from where I need to subtract? Now I know that from 0 to infinity, what is the half area equal to? Half area is equal to 0.5. So from this half area, if I am able to subtract this portion which is can be obtained from the table from 0 to 2, then my required portion of that yellow beyond 2 will be obtained. So keep in mind greater means subtract. So probability of z greater than or equal to 2 is from your total half area 0.5 subtract the value from 0 to 2. So 0.5 minus what is 0 to 2? 2 I can write it as 2.00. So go search for your 2.0 and next 0. So where is going to be 2.00? 2.0 and 0. So it is going to be 0.4772. So when you subtract this, what will happen? Answer is 0.0228. So the value for z greater than or equal to 2 is 0.0228. Now for the second region, x less than or equal to 20. So we want probability of x less than or equal to 20. So now what we will do is, we will have our table fixed over here. We want the probability of z less than or x less than or equal to 20. Now this problem in x, let us convert it into z. Z is x minus mu divided by sigma. So it is 20 minus 12 divided by 4. So it is again 8 by 4, which is going to be equal to 2. But what happens here? It is z less than or equal to 2. Now when we have the graph to be plotted, this is our graph, the bell-shaped curve. Now we will have the center line at the point z equal to 0. This is my point z equal to 2. Okay, so I have z equal to 0. This is my z equal to 2. Now I want is less than 2, LAD. So whenever it is less, you need to add. Why we need to add? This is because when I want the lesser than 2 portion, from where? From 2 to the end minus infinity, I will have to find out what is going to be the portion. So this is going to be the entire portion for which I require the probability for. Now I know that the table can give me the value only from where? The center line. So from the center line, I will be able to find this 0 to 2. But how about this portion which is going to be beyond the center line? So we know that half area is equal to 0.5. So whenever you have less than or equal to, then what you will have to do? You will have to add with it. So what you will have to do? With 0.5, you add probability of 0 less than z less than 2. So with 0.5, you add 0 to 2. So it is 2.00. So it is 0.4772. So 0.9772 will be your final answer. Now this completes the second subdivision. How about the third subdivision? We want probability of 0 less than x less than 12. Now what will happen to this 0? Z equal to x minus 12 by sigma. When x takes the value 0, it is going to be 12 divided by 4. So 12 by 4 is going to be equal to 3. So this is minus sign, so minus 3. So the 0 will be converted as minus 3 less than x will become z. How about this 12? So 12 minus 12 by 4. So this will become equal to what? 0. So the quantity which was 0 less than x less than 12 will now turn out as minus 3 less than z less than 0. So which is going to be the portion for me now to shade? So let me now draw the diagram and then plot the region for. This is going to be my line z equal to 0 minus infinity to plus infinity. Where will be the line minus 3 lie? This is going to be my line z equal to minus 3. I want the region between it. So I want this portion which is going to be between minus 3 to 0. But do you find any negative values in this table? No, right? So how to find the negative values? I know that the value over here in the negative is the same as the value over here in the positive zone. Why? We know that the graph is symmetric in nature. So how much ever I want in z equal to minus 3, that is the same available for z equal to 3. So when I estimate it between z equal to 0 to z equal to 3, that is this region is the same as the upper region. So how to go about this data? The third data, probability of minus 3 to 0 is the same as this. So it is the same as 0 less than z less than 3. So go for your 0 to 3. Where is 3.0? Here 3.00. So what is the answer? 0.4987. So this will be the final answer for the 0.4987 is going to be the final probability of the value of x lying between 0 to 12 on conversion from 0 to 3. I hope you understood the region plotting and evaluating the data from the table. Always keep in mind the table is evaluated only keeping z equal to 0, the center line as the base. So when you want a greater region, then you go for subtraction. GST, greater means subtract it from 0.5. Whenever you want a lesser region, then LAD. LAD means less means add. So when you have a value for less than, then you add your 0.5 with it. So if you keep these two code words in mind, then your problems can be solved very easily. Thank you.